Hi, this video will focus on solving quadratics by completing the square. And these steps are very similar to the steps that we followed when we were rewriting the quadratic equation into a vertex form. So go ahead and pause the video, copy down these steps, and then I will walk you through a few examples of following these steps. Right, the process of completing the square is different from factoring or graphing, and the fact that we do not have to have it equal to 0. This one is equal to 0, but the first thing that we are going to do is we're going to subtract that 4, or move the 4, in this case we're going to add the 4 to the other side, so that I just get my square term and my x term. And that's what we did before, when we were very similar to what we were doing when we were rewriting in vertex form. So I'm going to move this 4 over, and I'm going to copy down my x squared minus 18x, and I'm going to leave that space and put the 4 on the other side. So I do what I did before. I take half of this, and again, it doesn't matter if it's positive or negative, but half of this is going to be -9, and then when I square it, I get a positive 81. This term is always going to be positive. Now, I've added 81 to the left, so now I have to add 81 to the right side of my equation, because whatever I do to the left, I have to do to the right to keep it balanced. This is now a perfect square. And we've talked about this with vertex form. I can rewrite it as something being squared. That something, I take the square root of the x squared, the sign from the middle, and the square root of the 81. And now I have that part. And on the right side, I get 85. Now this is like a problem that we were doing yesterday. So I have something squared. I need to square root it. Square root over here. The square and the square root cancel, leaving x minus 9. I have plus or minus, and I need to break down 85. Which is 5 and 17. And 5's prime, 17's prime, so they don't have any common factors. I don't have any pairs. So this is just going to stay the square root of 85. I still need to get the x by itself, so the 9 is being subtracted, so I need to do the opposite and add 9 over. So the answer is 9 plus or minus the square root of 85, which I would enter it as 9 plus radical 85, and then 9 minus radical 85. All right, let's look at another one. All right, so we're going to start and do the same thing. I need to move this c to the other side. So I'm going to add the 3 over. So I get 4x squared plus 4x, leave that space, equals 3. Now, I have this 4 out in front, and when we are rewriting into vertex form, we would factor that out. Completing the square to solve is actually a little bit easier because we can divide, since we have an equal sign, the entire equation by 4. So that means I divide each part by 4. So 4x squared divided by 4 is just x squared. 4x divided by 4 is just x. And then on the other side of the equal sign, 3 divided by 4 is just 3/4. So now I'm going to look at my b, which is 1. I'm going to take half of that 1, which is 1/2, and I'm going to square it. Now, if you need a calculator, you can use a calculator, but squaring fractions are really just a matter of squaring the top and squaring the bottom. So this is always going to be plus. 1 squared on top is 1, and 2 squared on the bottom is 4. And since I've added 1/4 to the left, I need to add 1/4 to the right. So again, I can factor this and write it as a perfect square. Square root of x squared is x. Sign from the middle is plus. Square root of 1/4 is right here, which was 1/2. Square that. And then on the other side, 3/4 plus 1/4 is 4/4, or just 1. Square root both sides to cancel out that squared. X plus 1/2 equals positive and negative, and square root of 1 is just 1. So I'm going to take this into two problems. X plus 1/2 equals 1, and x plus 1/2 equals -1. Subtract the half over. So x equals 1/2. Subtract the 1/2 over. And then I get -3/2. So those would be my two answers. Let's look at one more example. So this problem, they've already moved the 1 to the other side. I still need to get this to be just an x squared term, so I'm going to divide everything by 2. And you could either write it like this, or you can write each individual part being divided by 2. But those 2's cancel, leaving x squared. The 3/2 x, and I'm going to leave my space, and then I get 1/2 on the other side. Same thing as before, take half of this. And again, when you multiply this by half, it just doubles that bottom number. So this is 3/4 that I need to square. Squaring the top gives me 9. Squaring the bottom gives me 16. So on the other side, I need to add 9/16. So I'm going to work with the left and rewrite it as a perfect square, which is x plus 3/4. Because again, square root, sign from the middle, square root of this, which I had right here, which is 3/4. And on the other side, if I'm going to add fractions, I need to get a common denominator. So the common denominator would be 16. This is still 9/16, and if I multiply this bottom part by 8 to get 16, then the top becomes 8/16, which is 1/2. When you're adding fractions, recall that you add the top, so I get 17, and then the bottom stays the same, 16ths. Square root both sides. So this is x plus 3/4. And over here I get positive and negative. Now, when I am square rooting a fraction, I take the square root of the top, which 17 is a prime number, but 16 is a perfect square in 4. So now I need to move this 3/4 to the other side. And as I do before, -3/4 plus or minus radical 17/4. And those are going to be your two answers. You enter it once with the plus sign and once with the minus sign. If you have any questions, ask me in class.